Example: show that the cylindrical coordinates are theta and z defined by the relation x equals to r cos of theta, y equals to r sin of theta, and z equals to z. The Laplace's equation del square u equals to 0 takes the form del square u upon del r square plus 1 upon r del u over del r plus 1 upon r square del square u upon del theta square plus del square u upon del z square equals to 0. Solution: let x equals to r cos of theta, y equals to r sin of theta, and z equals to z. So x square plus y square equals to r cos square theta plus r square sin square theta, which implies r square into cos square theta plus sin square theta equals to x square plus y square, which implies r square equals to x square plus y square. Theta equals to tangent inverse y upon x, z equals to z. So r of x equals to x upon r equals to cos of theta, r of y equals to y upon r sin of theta, theta x equals to del theta over del x equals to 1 upon 1 plus y square upon x square into minus y upon x square equals to minus y upon x square plus y square equals to minus r into sin theta upon r square equals to minus sin theta upon r. Similarly, del theta y equals to del theta over del y equals to 1 upon 1 plus y square upon x square into 1 upon x equals to x upon x square plus y square equals to r cos of theta upon x square plus y square equals to r cos of theta upon r square. R to r cancel out, so equals to cos of theta upon r. Since u equals to u r theta z, so which implies u of x equals to u of r, r of x equals to u theta theta x plus u z zx equals to u r cos of theta plus u theta into minus sin theta upon r plus 0 equals to u r cos of theta minus u theta sin theta upon r. U equals to u r ry u theta theta y u z zy equals to u r sin theta u theta into cos of theta upon r plus 0 equals to u r sin theta plus u theta cos of theta upon r. U z equals to u r r z u theta theta z plus u z equals to 0 plus 0 plus u z equals to u z. Now uxx equals to uxx equals to ux r of x plus u of x theta x plus u of x z of x equals to ur cos of theta minus u theta sin theta upon r whole r cos of theta plus u of r cos of theta minus sin of theta u theta sin of theta upon r whole theta into minus sin theta upon r equals to urr cos of theta minus ur theta sin theta upon r u theta sin theta upon r square into cos of theta plus ur theta cos of theta minus ur minus ur sin theta u theta theta sin theta upon r minus u theta cos of theta upon r into minus sin theta upon r equals to urr multiplying the cos theta to this term cos square theta minus ur theta sin theta into cos of theta upon r u theta sin theta cos of theta upon r square minus ur theta sin theta cos of theta upon r plus ur sin square theta upon r u theta theta sin square theta upon r square u theta sin theta cos theta upon r square equals to urr cos square theta plus 2 ur theta sin theta into cos theta upon r plus u theta into sin theta into cos of theta upon r square plus ur sin square theta upon r plus u theta theta sin square theta upon r square equation 1. Similarly, similar to this equation, we will write uyy in place of x. We will write y uyy equals to urr cos theta place of sin theta sin square theta plus ur theta sin theta cos theta upon r 2u theta minus 2u theta sin theta cos of theta upon r square plus 2ur cos square theta upon r plus u theta sin square plus cos square theta upon r square equation 2 and uzz equals to uzz. Adding equation 1 and 2 and 3 we get uxx plus uyy plus uzz equals to urr cos square theta minus ur theta sin theta cos theta upon r plus 2u theta sin theta cos theta upon r square plus ur sin square theta upon r plus u theta theta sin square theta upon r square plus urr sin square theta plus 2ur theta sin theta cos of theta upon r minus 2u theta sin theta cos theta upon r square plus ur into cos square theta upon r plus u theta theta cos into cos square theta upon r square plus uzz equals to urr cos square theta plus sin square theta ur into cos square theta plus sin square theta ur upon r into sin square theta plus cos square theta plus u theta theta upon r square equals to sin square theta into sin square theta plus cos square theta plus uzz equals to urr plus 1 upon rur plus 1 upon r square u theta theta plus uzz. or del square u equals to urr plus 1 upon r ur plus 1 upon r square u theta theta plus u z equals to, hence the Laplace equation is equation in cylindrical coordinates is equals to urr 1 upon r ur plus 1 upon r square u theta theta plus u z equals to 0.